This visualization shows the massive scale of competitive PC gaming. But if we zoom in right here, this distinct red sliver represents about 0.7% of all ranked matches. That tiny fraction is where high-paying cheaters infect the game. To fight them, Riot Games built Vanguard. It's an anti-cheat driver that has historically launched the exact moment your computer turns on and stays running in the background, a design choice that has raised plenty of eyebrows. The reason for this invasive design comes down to a security dilemma known as the who loads first problem. If a cheat boots up before the anti-cheat does, the cheat wins. It can map the system and hide itself completely. By getting their code into the kernel, the core of the operating system, cheaters bypass standard user protections. They turn Windows into a glass house where they can see and manipulate everything, totally invisible to normal software. Because these early loading threats dictate the environment, traditional software-based anti-cheats had to maintain total omnipresence. The only way to guarantee a fair match was to stand guard from the second you pressed the power button. But that approach is changing. With a new update called Vanguard On Demand, the anti-cheat driver can now sleep. It only wakes up and launches when you actually open a Riot game. There is a catch. This sleep mode is only allowed if your physical PC hardware meets a strict set of modern cryptographic security requirements. Instead of relying on an invasive piece of software to police the operating system, Riot is moving the burden of defense back to the native physical architecture of the PC itself. To understand this, we trace the boot path from hardware to the OS. Before Windows loads, actors use modified USBs to inject bootkits. Secure Boot stops this. It uses private motherboard keys to cryptographically verify the bootloader, outright rejecting any unsigned malicious code. Locking the boot process means the operating system can't be compromised at birth. It eliminates the foundational layer of early loading malware before it reaches the game. At the expansion slots, cheaters use $6,000 custom direct memory access hardware to read game data straight from RAM, bypassing the OS. To stop this, the IOMMU drops in as a physical firewall, severing that direct line and forcing requests through a strict translation table. When attackers bypass software with custom, expensive physical devices, the only effective defense is a literal hardware-level blockade protecting the memory. Inside the OS kernel, cheaters use the Bring Your Own Vulnerable Driver exploit, sneaking malicious code through outdated drivers. The fix uses hardware virtualization, VBS, and HVCI, creating a secure enclave at ring -1 that sits above the OS to block bad drivers. By elevating security privileges to a level structurally above the operating system itself, attackers can no longer rely on traditional loopholes within Windows. But this brings up a paradox. If Vanguard is asleep while all these defenses are running, how does it mathematically know the system was actually secure when you finally launch the game? The answer is the TPM 2.0 crypto processor. Using runtime driver attestation, it silently generates a continuous, immutable hash of every loaded driver. When Vanguard wakes up, it checks this unhackable mathematical receipt, instantly confirming the system's integrity before you play. Leveraging a motherboard's native crypto processor replaces the need for 24/7 software surveillance. It replaces constant monitoring with instant, undeniable mathematical proof. This chart shows the current state of adoption, and right now, about 35% of players are already running machines in this fully secured core state. For those players, Vanguard sleeps. They get their system resources back, increased privacy, and an icon removed from their taskbar. But for cheaters, the penalties have escalated. Because the TPM key is physically burned into the motherboard at the factory, bypassing a hardware ban now requires physically desoldering and replacing the banned chips. Hardware-level enforcement radically changes the economic and logistical math. It makes cheating wildly impractical and highly expensive for the average bad actor. This hardware shift is happening just in time to meet the next major threat, AI. Computer vision pixel bots with perfect aiming algorithms are rapidly becoming cheaper and easier to acquire. Because these tools can be processed entirely on external hardware, purely software-based anti-cheat routines are struggling to keep up. We are entering an era that requires a proof-of-life layer for digital competition. To verify a fair match, the physical endpoint playing the game, the machine itself, must be verified and trusted. Vanguard's on-demand update proves that the future of fair play doesn't rely on treating every single player as a suspect. It relies on trusting the verified physical architecture of their machine.